Good morning, folks. This is first lecture of week 12, and we're almost done with the course, almost. Now, on the agenda today is I'll show you how to use a design table for an assembly problem. Let me remind you that starting last Tuesday, I did the problem for parameterizing a single part. Then the following day, which is Thursday of last week, I did parameterizing an assembly, okay? Then in Friday's lab, the 15 minutes at the beginning presentation, I did design table for a single part. And now I'm going to do the same thing, namely creating a design table for an assembly or a product. And the one comment that I'm going to make, and this applies both to the cases where you parameterize an assembly or you create a design table for assembly. If you're dealing with parameters there, and you do, make sure that you define it at the product level. In other words, make sure that before you define your parameters, you are all the way at the top at the product level. Do not do it within a part, okay? Now, the first problem that we're going to do is creating a design table for this very simple assembly. I have already created the Excel spreadsheet, and this is the top left corner of the spreadsheet, and I've copied it here. And notice that the things that are specified here, the radius of this inner inner cylinder must match the radius of the hole, and that's the one thing that we have to do. Now keep in mind that there's two ways of doing this problem. Because the spreadsheet is given like that, you have the option of making this radius equal to r and that radius equal to r. That's one option. Or the other option is to make this radius equal to that radius, and then the radius of the hole equal to r. That's entirely up to you. So what I'm going to do is exactly that. In other words, I will make this radius, the radius of the cylinder, equal to the radius of the hole. So that's an equation. And then the radius of the hole equal to the parameter which is described in this spreadsheet. Okay, good. So let's go ahead and start with the product file. Immediately save it. So file, save management, save as. I have a folder called August 1. So I have August 1. Okay, so I'll make a folder. Yeah, new folder, and I'm going to call that thing problem 1. Problem 1. Okay, and this product is going to go in it. Okay, let me do the cylinder first. So insert a new part in there, and I'm going to call this thing cylinder, properties sil. And let's drag this thing down so that it's bigger right here. Sil. Okay. All right. Oh, incidentally, I just remembered that L box and L cylinder are not necessarily the same, so that's fine. So let's make it. Double click on this. On that plane, I will sketch. I'm going to put a circle here and dimension it, and exit and path. Okay. All right. Now let's go all the way to the top. Insert a new part in there, and I'm going to call this thing a box. Right click properties, box and box. Box and box. Yep. Okay, and let's make it. So on that plane, I will sketch a rectangle with a circle in the middle, and you know how to make it in the middle. So this line control that line, control the center, equidistant. That's one way of doing it. This line control that line, control center, equidistant. Okay, very good. And now let's dimension the stuff that we want. So this radius we want, that length we want, and this length we want. Exit, padded. Okay. Now we go all the way to the top, all the way to the top. Okay. And we create our parameters while we're here. So f of x, all our parameters are of type length. So one is L cylinder, L sil, right? Let's make sure that this is correct. The spelling. Oh, L, big L sil. Yeah, that's good. And let's give it a nominal value. I'm going to use these nominal values, 1 and 1. Okay, 5 and 5. Okay, 1. I'll make it 1. 1. Another one. Let me see now. L box. Okay. L box. Also 1. Another one R. R. And the value of R is, the nominal value is 1 also. 1. I noticed that inadvertently I created something called L length 3. So I might as well use it. A, nominal value 5. Is it L, A? What did I call this thing? A, yeah. A, nominal value 5. Another one, B, nominal value 5. And then apply. And first, let's check the parameters here. These are the parameters that appear in our Excel spreadsheet. Okay. Now, I said that the approach that I'm going to take is making the radius of this cylinder equal to the radius of this hole. So how do I do that? I go to f of x. I click on the product. Here is the radius of the cylinder. Add a formula equal to the radius of this hole. You say OK. All right. So the reason that this became red is that this radius is not the same as what it was here before. That's why it wants to update, but I'm not going to do that. Okay. So let me see now. That's pretty much it. Apply, OK, and update. See, now these two are exactly the same radius. Believe me. Let's check it out. Use the caliper. This is 0.88, and this is also 0.88 because I made them the same. Good. Now we're going to go to the design table. Problem 1. Problem 1. It says, do you want me to automatically associate? The answer is yes, and it already did. Okay, so let's check it out. This is the first row that already have the same, already have that information. That says nothing update. So let me remind you to go to this, to go to your, what is it? To go to your design table, you just double click on this. Don't make another one. Next row, apply. Okay. uh, something 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 is not quite right here. Why is this thing not updating? Notice that nothing is updating because notice that as I select different row, the design table has been created, but nothing is updating. And the reason is that I did not create my relations. Okay, so basically, these things are not associated with any of my dimensions here. So let's go back. Let's go back here. F of x. I just forgot. As simple as that. Okay. So you click on the product. Okay. That's the step that I forgot. So I want select this. Add the formula equal to a. Okay. Good. Then select the other dimension. This guy. You see that? This guy. Add the formula equal to b. The radius of the hole, add the formula equal to r. And L box, so L box is this 0.787. See that? It says box, first limit. Add the formula equal to L box. And the other fellow is here. This is the cylinder. See that? Cylinder first limit. Add the formula equal to L cylinder. And okay. And okay. Now update. There. See that? Now notice that the reason that these are different thicknesses is because if you look at your design table, we are dealing with this row. So the height of the box is 1, excuse me, and the height of the cylinder is 0.2. If you go to the top row, apply, can I update here without closing that? Yeah, well, it closes that. So there, these are the same height, 1 and 1. And of course, the things match. See that? A and B are both 5, so that's the square, and the radius of this hole, which is equal to the radius of the cylinder, obviously is 1. Now, let me see now for a second. We say okay here. Let me see now. I wanted to tell you something, and that is, let's save this thing. And I'm going to close this. And do not forget that when you give us that particular file, namely product, and there are 2 parts in it, box and the cylinder, also give us the Excel spreadsheet. Let me see if I can find my folder here. We called it August something, right? August, right there. This problem 1 Excel spreadsheet should go in that folder. And what you upload for us, if this was a test problem, for an exam problem, you give us the product, you give us the 2 parts, and you give us the Excel spreadsheet. Okay, so let me close this, and I'm going to go to a second problem. The second problem is here. We have a cylinder and a cap, and the Excel spreadsheet is given there. So H, R, L, and alpha are things in that spreadsheet. So, oops, what is that? Let me see now. H is this thickness, the thickness of the cylinder, and the thickness of the cap. Alpha is that angle, okay? And let me see now, L is that height. The height from the very bottom to the very top, okay? So let's go ahead and make the nominal parts, namely the cylinder and the cap, and then we do the rest of the problem. Let's go here. We start with the product file. Immediately save it. File, save management, save as. I'll make a new folder here, problem 2. problem 2. Okay, I'm going to put this in the problem 2. Let's do the cylinder. Okay, so let me see now. Insert new part in there. I'm going to call this thing cylinder. I'll call it cyl. How about that? Cyl and cyl. Okay, let's make it. I'm going to draw something and then shaft it. How about that? So we go on that vertical plane. I will draw something like that. And we'll clean it up in a minute. Okay, so let's see now. This is going to be the L. Yeah. And let me see now. This is all H, right? So here's what I'm going to do is I'm going to say, okay, so there is a dimension here. And that dimension is going to be equal to, or we can say both of these are equal to H. That's one way of doing it. Okay, no problem. Again, remember in this problem, what you can do, you can make, for example, this is equal to that, or this is equal to H, and that is equal to H. This is equal to that, and one of them is equal to H. That's one way of doing it. Or basically, this dimension equal to H, and that dimension equal to H, and that dimension. I leave it to you to decide how you want to do this thing on the test. It really doesn't matter. As long as your design table works and produces the right stuff, I don't care how you do it. Okay? Now, the other thing is this is radius. This is going to be my radius. So I need to dimension it. And there's this angle, alpha, right? So I'll make that the angle between this line and that line. This is going to be alpha. Good. Exit. Shaft it. Where's shaft? Oops, shaft is right here. About the z-axis. Z-axis. But not by 360. I'll make it 180 because I want to get the exact same kind of geometry that you see there. Okay, good, good. So let's go all the way to the top. Insert new part in there. And I'm going to call this thing the cap. Right click properties, cap, and cap. Let's make it. So on that plane, on that same vertical plane, I will sketch the cap. Again, I'm going to do the shafting. So it's going to be something like that. We'll clean it up in a minute. Okay, so let me see now. This dimension is R. This dimension is going to be, I'm going to make it equal to H. So I decided to go the long way. This is equal to H. This one is equal to H. That one is equal to H. There are alternatives, and that I did just like in the first problem. Okay, and the angle between this line and that line, this angle is going to be equal to alpha. Okay, or I can set this angle equal to that angle and that angle equal to alpha. It's again, I leave it to you. Okay, so exit and shaft it about the z-axis, 180 degrees, and there we are. I mean, I might as well, yeah, I'll change the color of that thing to brown. Not an issue here. Okay, good, good. Oh, you know what? I just realized something. In this problem, do not forget to put the assembly constraints if asked. In other words, axis to axis, bottom plane, for example, to the bottom plane. You remember, if you are asked to do that and you don't do it, you will lose marks. Okay, so I'm going to do that in this problem. I forgot to do it there. I'm going to do it in this problem. Okay. All right, let's go ahead here and okay, this is all done. What do we save everything? Let's create our parameters. I don't need this. I don't need this. Remember, you have to be at the top level, at the product level. So you click on f of x, parameter length h. And why don't I use one of these as the guideline? So h equal to 1, r equal to 3, and alpha 45. Okay, so that's good. Another one, r, what is that, r? R equal to 3. Yep. And another one, L is going to be the length of the pad. It's going to be 6 later on. 6. And now angle alpha, so we change this thing to angle. Click on it, alpha 45. 45 apply. Good. So now we're going to define our parameters. And we did define our parameters, now our relations. So all you do, you click on the top. I want this guy, add a formula equal to R. I want this height, add a formula equal to L. This angle, this thing, add a formula equal to alpha. And where's the H? Let's see, there's two H's here. One is that fellow up here. This guy, add a formula equal to H. And because this has the same thickness, this guy, add a formula equal to also H. That takes care of these fellows. Now let's go on the top here. This guy from the cap, add a formula equal to R. There's a thickness here, add a formula equal to H. Remember, I'm doing it the long way. And this angle, add a formula, not that one. There was, I hope I did not pick the wrong angle there. There was an, oh, this angle. Add a formula equal to alpha. And let's hope that I didn't make any mistakes. Now, these are the values, right? This H actually, I don't want it to be 0. I want it to be, what was the value? 1, okay? It was supposed to be 1. Now, if I update, these are going to be the values that are going to be used. Let's check before doing the design table. I haven't done the design table yet. Good, see that? The angles match, the radii match, the thicknesses match, okay? Now, should I make assembly constraint? This is the thing that I forgot last time. So, anchor this. Coincidence between, for example, this, let me see now. For example, different ways of doing this thing. Let me see. How about doing it like this? Now, if I do coincidence, the problem is that these curved surfaces, it's going to take the axis. Well, actually, let's try that. Axis of this and axis of that, and then contact between this face and that face. Remember, I haven't done design table yet. Update, no problem. Let's check something before we just pretend that this is the right thing, final thing. as far as the assembly constraint. Let me rotate. I'm going to rotate about that axis and say update. You see, that was not good enough. Okay, so let me undo that. There's one more constraint, and that is coincidence between this plane and that plane. It was not good enough last time. Now let me try to do that now. So suppose that I rotate about this axis. You see that? Before, when there was no update. Now I update and it comes back. Okay? You do any crazy rotation here and any crazy translation. When I update, it should go back to where it is. You don't want to lose marks on this. This is what I forgot on the first problem. Okay? Now we have to create our design table, because this is not the design table. You click on it. You say, okay, I have already created that. It's problem 2. You say, okay. Hopefully the spelling and everything is okay so that everything is taken account. Oh, yeah. Something is not. And that is, you see, these are okay, except that what is missing here is L. And if you click on the association, it says, I don't know what this L is, right? I don't know what this L is. So let me cancel that. Let me cancel that. Let me go, because if you select, I'm pretty sure I forgot to do the equation. If I double click on this and I change this thing to 12 and I say okay, so that's good. It must be then that in my spreadsheet I have a bad spelling or something. Let's check it out. Let's actually go there. Okay, I'm going to delete this spreadsheet. I'm going to actually let's double click on it. Let's double click on it. Let's see what the spreadsheet looks like. Oh, not that. Cancel. Sorry. I guess it's easier if I deleted it. Let me check my spreadsheet here. First of all, I don't want this thing to be in that folder. I want it to be in this folder, because once your time is up and you have to submit your work, no want to forget about doing this. What is the name of that thing? Extra parentheses. You see that? You see that? Extra parentheses. So we say, okay, we close it. We go here. It was possible to fix it there too, but I thought we do it quickly. So let's do another design table. The first one I deleted. You say okay, and there is my problem 2. I bet L is going to appear in the list here, right there. Okay, so let's check it out. This one, apply and update. There we are. Double click. Next one. Okay, update. There we are. See this? And next one. Okay, and update. There we are. Yes. Yep. There's nothing that stopped it from here. Remember, because these thicknesses were assumed to be the same, it can actually have a configuration like that. There's no problem. All right, folks. So that took care of this problem.